Good afternoon, sir. Should we start, sir?
Yeah, we can start. Sanjay, are you there?
Yes, sir, I'm here only.
Yes. So, how are you? Hello.
Yes,
I
sir.
Hello.
would like to welcome you to this.
Yes, sir.
Nice.
Yes, sir. So, good afternoon, everyone. On behalf of the Department of Biotechnology and Bioengineering, School of Biosciences and Technology, Galgotias University, I extend a warm welcome to all respected guests, invited speaker, dean sir, faculty member, student and participant of this workshop titled AI and Industry 4.0 Tools for Healthcare Innovation and Entrepreneurship. We are delighted by your presence and thank you all of you for joining us with this afternoon for what promises to be an insightful and engaging session. So it is now my privilege to invite our esteemed Dean, Sir Professor Abhimanyu Kumar Jha, Dean School of Biosciences and Technology, Galgotias University, to deliver the inaugural address and formally open today's workshop. Sir, the virtual dais is yours.
A very warm good afternoon to all of you. I would like to welcome you all for this contemporary webinar or contemporary expert talk which we have organized today. And this is going to be a great one because this is the need of these days. Artificial intelligence is playing a big role everywhere. Artificial intelligence is for all of us to see. Like to tell you, the students must be remembering the students from our school of biosciences and technology at Galgotias University, and our faculty members must be remembering that just in the last board of studies proposed a particular subject, particular course, that is artificial intelligence into science and technology, because we accept and we all have to accept the role which is playing not only in the field of biosciences and technology, but also the piece of innovation and entrepreneurship. And that's why we are here with you for this contemporary expert talk, which is going to be delivered by Dr. Sanjay Saxena. And we are going to understand what role AI and Industry 4.0 tools are going to play in the field of healthcare innovation and entrepreneurship. I would like to tell you that biosciences and technology is a field which has been there, in which we say that this is a life in which we work on living organisms. We work on different types of microorganisms, as well as different types of things like robots, biomechanics, and so on. But still, AI has made it a revolutionary concept, and AI has a lot to help in the field of biosciences and technology as well, in addition to healthcare, innovation, and entrepreneurship. With this in mind, we were thinking of having a speaker who can put into the best way and come out with some good things to tell our students about the importance of AI in these particular fields. We all have gathered here for this talk. It is our good Dr. Sanjay has accepted our invitation. Dr. Gaurav played an instrumental role in this, and Dr. Gaurav, the HOD of Department of Biotechnology and Bioengineering, Biosciences and Technology, he had talked to Dr. Saxena. He had requested him, and Dr. Saxena agreed for this talk. And we are thankful to you, Dr. Sanjay, for accepting our invitation. And I would like to ask our students also to come out with inquisitive doubts, inquisitive queries, and get their queries cleared so that we can learn from him as much possible. And this is an important thing, that AI is there and AI is going to support us. AI is not going to overrule the natural intelligence. It's just going to support the natural intelligence because it is, after all, artificial intelligence. I would like to thank our Honorable Chancellor, our Honorable CEO, sir, our Dynamic Director Operations, as well as our Honorable V, sir, for always put us and motivating us, organizing events. They have always been supportive and always encourage us to move on with the events for benefit and updation in knowledge of our students as well as our faculty members. And I also thank Dr. Sanjay for accepting our invitation. And I would like to commend the efforts of Dr. Gaurav and the other members of Department of Biology and Bioengineering, School of Biosciences and Technology, for coming out and organizing a particular event at a very important time, which is very much the requirement of the hour these days. And with this, I would like to thank all the audience for coming out in good numbers. And let's go ahead with the talk. Thanks a lot to all of you.
Thank you so much, sir, for encouraging and visionary address. We now move to the most anticipated segment of today's program. It's give me immense pleasure to introduce our distinguished invited speaker for the session. We are honored to have Dr. Sanjay Saxena, sir, Assistant Professor, Department of Computer Science and Engineering, Indian Institute of Information Technology, IIIT Vadodara, with us today. Previously, Saxena sir has he was with the IIIT Bhubaneswar for 9 years with a PhD from IIT BHU and postdoctoral research at the University of Pennsylvania. His work focused on the intersection of AI and healthcare. Dr. Saxena specialized in applying the AI, machine learning, and deep learning to advance cancer diagnostics and treatment, particularly in the brain tumor. He also served as a CEO of Research Innovation Project Incubation and Technology Transfer Foundation in IIIT Bhubaneswar, and he led the initiative in the research, innovation, and technology transfer at the same institute. He is also at the forefront for the developing the artificial intelligence based method for the healthcare in IIIT Vadodara and actively contributes to the fostering the interdisciplinary research. His notable academic contribution includes numerous presentations and publications on AI application and medical imaging and radiogenomics. So beyond his academic pursuits, Dr. Saxena is passionate about mentoring young researchers and collaborating on projects that drive the technological advancement in healthcare. He has published several research papers in high impact research journal of reputed publishers as well as in the IEEE conferences. I I cordially invite Dr. Sanjay Saxena sir to deliver the invited talk. Sir, we are delighted to hear you with us. So over to you, sir. Thank you for the accepting our invitation
No,
also.
no, not at all. Thank you, Dr. Gaurav and Dr. Abhimanyu, for having me. And am I audible? Actually, we
Yeah,
are facing
yes, sir, you are audible.
bandwidth issue since morning. So thank
Yeah,
you
yeah.
for having me. And it's my great pleasure to speak a little bit whatever I know regarding AI in healthcare in the today's era. So, as you are right, Dr. Abhimanyu, that we are living in the era of artificial intelligence, and this event is very crucial because how we can make a good AI-based methods for the industry perspective. It will help us run young researchers a lot in today's era. So that is a very nice initiative, and I would be happy to discuss whatever the little knowledge I am having in this field, whatever I have gained in last couple of years. So I will be sharing my screen, and it will be great if this conversation will be bi-directional. I request all the participants, if you are having any doubts, then you can ask, so that it will be great for you as well as for me to understand and to discuss the things properly. Okay, so Dr. Gaurav, I will be sharing my screen, and apologies from my side because I am facing a little bit bandwidth issue. So I will have to, I think I am stopping my video and I'm sharing my screen.
Yes, sir, you can.
Okay,
And sir, during sharing, you can stop the annotation.
okay.
Yes,
One,
because some participant have joined with not with their name and they are annotating on the PPT. So you can disable the annotation, sir.
okay. So am my screen is
Yes,
visible?
sir, it is visible, sir, perfectly.
One.
Yeah.
Okay, so today, as I told, I'll be speaking on artificial intelligence and industry in healthcare from algorithms to impact. So basically, this talk is not about the hype or not about the futuristic fantasies. It is about where AI truly stands today in the field of healthcare. So how industry is translating AI into real clinical impacts and what lies ahead. So I will try to discuss these things. So I will be discussing about the algorithmic and methods perspective, as well as I will be discussing about the little bit about the artificial intelligence, machine learning, and deep learning, and how we can make the appropriate methods more suitable for the industry perspective. So basically, why this topic matters. So let me begin with the explaining why this topic is so important today. So healthcare system across the world are facing a fundamental imbalance. So the complexity of the healthcare is increasing much faster than the available manpower. Explosion of the multimodal clinical data. So we are having a couple of different type of clinical data, like it includes medical images like CT scan, MRI scans, electronic healthcare records, laboratory data, genomics. We are having wearable sensors, continuous monitoring streams, and so on. So while the data holds significant amount of value, human cognition alone cannot fully process or integrate it in the real time. So for that, we need for a scalable intelligent decision support. So that's why AI comes into the picture. So industry basically enables translation from lab to the bedside. So this topic is very important because we are having enormous amount of data around the globe, and based on that, we can train our model based on artificial intelligence, machine learning, deep learning, agentic AI, and so on, so that it can be very helpful for the human perspective. So, so now let us look at where the real opportunities of AI in healthcare lies. So basically, this slide summarizes the four major impact areas where AI is already creating value and where industry investment is rapidly growing. So firstly is enhanced diagnostic and imaging. So this is one of the most mature and successful application of AI in healthcare. So AI systems can assist clinicians in detecting abnormalities in radiology, pathology, and other imaging modalities, which often basically faster and with high consistency. So the goal here is not to replace radiologist or pathologist, but to improve accuracy. So basically, that is very helpful for the reducing the fatigue and that will prioritize critical cases. Second is the personalized treatment plans. So every patient is different genetically, biologically, and clinically, as we all knows that. So AI enables us to move away from one size fits all machines towards a data driven personalization. So by integrating imaging, clinical history, genomics, and the response patterns. So basically, this is particularly impactful in areas like oncology, various chronic diseases, and then the precision medicine. The third one is the predictive analytics for the patient outcome. So AI can help answer forward-looking questions like who is at the risk of deterioration, who may benefit from a specific therapy, who needs closer monitoring. So these kind of predictive capabilities support early interventions, better prognosis estimation, and the proactive care rather than reactive treatments. So we can have a couple of models so that we can create a predictive modeling. Finally, efficient healthcare operations. So like a significant portion of the healthcare cost and inefficiency lies outside direct clinical care. So AI can optimize hospital workflows such as, for example, uh, bed management, utilizations of the ICUs, I mean, scheduling of the operations, supply chains, and various administrative processes. So basically, that leads to better resource utilization and reduce clinical burnout. So, the healthcare AI opportunity is not limited to the algorithms or models. So basically, it covers clinical quality, patient outcomes, operational efficiency, and system level sustainability. So So this is about the healthcare based AI opportunity. So the question you must be thinking, like, will AI replace doctors? So this is the probably the most common and most important questions where we talk about AI in healthcare. So this is very subjective, but the short answer we can say that it is no. So AI is exceptionally good at processing large volume of data. We know that it recognizes the patterns and performing repetitive or well-defined tasks. So however, medicine is not just a pattern recognition problem. Okay, so that is why we can say that the AI is not going to replace doctors. So doctors do much more than diagnose. They listen, empathize, make ethical judgments, handle uncertainty, various kind of uncertainties, and take responsibility for decisions that directly affect human life. So these aspects for of care cannot be automated. So AI cannot do that. So basically, what AI can do, AI is basically the augment doctor. So it can reduce cognitive overload, automate various kind of a documentation, assist in diagnosis, and help prioritize cases, which allows clinicians to spend more time with patients rather than screens. So basically, in practice, we can say that AI functions like a very powerful clinical assistant, which is similar to how stethoscope, imaging, laboratory tests extend medical capability in the past. So the future of healthcare is human centered AI assisted medicines, where technology supports expertise, but responsibility and the compassion remain human. So AI is not going to, this is a very subjective topic, but in general we can say that AI is not going to replace the doctors. So, like for example, it is, we have I have mentioned a couple of points here. So AI augments clinical intelligence, not basically clinical judgment. Human empathy, ethics, and the accountability remains irreplaceable. AI reduces cognitive and administrative burden. Clinical context and nuanced decision making requires human expertise. The future belongs to the doctors who work with the AI. So this is, we have to keep this thing in our mind, like AI is not going to replace the doctor. So it can help the doctor, but it cannot uh, replace the doctors. So this basically quote captures the essence of how AI should be viewed in healthcare. So AI won't replace doctor. What it will replace is repetition, the routine, time consuming, and cognitively draining tasks that consume a large part of clinicians' day. So in today's healthcare systems, doctors spend significant time on documentations, repetitive imaging reviews, many kind of imaging reviews, administrative workflows, and protocol-driven process. So these are the precisely the areas where AI perform best. So by automating various kind of repetitions, AI frees clinicians for innovations, for deeper thinking, complex decision making, research, teaching, and most importantly, meaningful patient interaction. So this shift is not about reducing the role of doctors. Basically, it is about the elevating the role of the doctor. So when clinicians are freed from repetitive work, they can focus on what humans do best, like understanding the context, exercising judgment, showing empathy, driving medical innovation. So the real promise of AI in healthcare is not substitution, but it is basically a liberation. So liberating human expertise from routine tasks, and basically that allows it to be applied where it truly matters. So what is AI in healthcare? So now that we have addressed what AI is not, let us clearly define what AI actually is in the context of healthcare. Okay, so as its core, AI in healthcare is data-driven clinical intelligence. So basically, it refers to the computational systems that can learn from large and complex medical data and assist clinicians in making better informed decisions. So basically, one of the AI's key strength in is pattern discovery beyond human perception. So healthcare data is often high dimensional and multi-modal, like images, signals, text, text data, lab laboratory data, genomics data. So if we talk about the images, so there are a couple of kind of images are there, like various kind of MRI, CT scan, PET scan, and so on. So this is having a high dimensional data. So while humans are excellent at reasoning, AI excels at identifying, I mean, subtle correlations and trends across these diverse data sources that may not be immediately visible to the human eye or mind. So that AI, in that case, AI plays a very important role. So importantly, AI does not replace clinical expertise. What it does, it instead of it, it supports diagnosis, prognosis, and the treatment decisions by acting as an intelligent assistant which highlights risk and suggests various possibilities and providing evidence-based insight. So if you look at the diagram on the right side, you can see how broad the applications of AI in healthcare are. So AI is already being used in the uh, like diagnosis of disease, which improves early detections, medical image analysis, especially in radiology and the pathology side, drug discovery, which accelerates target identification and the molecular design, personalized medicines, which tailors therapy and the for a particular individual patients, electronic healthcare records that extracts insight from the clinical text, clinical trials, which optimizes patients' recruitment and outcomes, outbreak predictions that basically supports the public and health decisions, and even in medical robotics. So that I forgot to discuss, it assists in the procedures and various care delivery. So AI in healthcare is best understood not as a single tool, but as an ecosystem of intelligent technologies that supports the entire range of care. So from prevention and diagnosis to the treatment and the various kind of populations of health. So in summary, we can say that AI brings scale, consistency, and analytical depth to the healthcare, while clinicians bring judgment, empathy, and the responsibility. So together, clinicians and AI, they form a powerful partnership for the future of medicine. So, so basically, this slide helps us understand how the different AI technologies we hear about actually that are related to each other. So let me explain this diagram from outside in, because that is the easiest way to interpret it. Okay. So at the outermost level, we have artificial intelligence. So AI is a broad umbrella that includes any computational system, basically that is designed to mimic aspect of human intelligence. So I used to say artificial intelligence, intelligence which is artificial, that is called artificial intelligence. So that is a broad umbrella. So that is designed in such a way to mimic the aspects of the human intelligence, such as human intelligence is having like reasoning, learning, perception, and decision making, and so on. And inside AI, we have machine learning. Machine learning basically refers to the system that learns pattern from the data rather than being explicitly programmed with the various kind of rules. And most AI system used in healthcare today, like for example, risk predictions models, clinical scoring system, and so on, falls under the category of the machine learning. So going further inside, we see the deep neural networks. So deep learning is a subset of machine learning that uses multi-layer neural networks. This basically paradigm has been particularly transformative in healthcare because of its success in medical imaging, various kind of signal processing, and the complex pattern recognition based problems. So deep neural network played a very important role, because it is very useful when we are not able to identify the particular set of features from an image. So in that case, convolutional neural network played a very important role. So now within the deep learning, we can see that there is a transformer model. So transformers introduce a new way of modeling long range of dependencies in the data, and recently it have become the foundation of many modern AI based systems, specifically in language and multimodal uh, learning. At the center of the diagrams, we can see that the large language models, or shortly we can say that the LLMs, everywhere in the, I mean, the last couple of months, not couple of months, like last years, last 1 or 2 years, we are listening continuously about the various kind of large language models. So these are the transformer based models that are trained on the massive amount of text data. For example, that includes models such as GPT based, but like models and various kind of others models. So in healthcare, LLMs are increasingly used for the clinical documentations, summarization of the clinical reports, decision supports, and knowledge based assistance. So with the appropriate explainability and so on. On the right side of the diagram, you can see that generative AI, which overlaps with several of these paradigms. So, generative AI refers to the models that can create a new content like text, images, audio, or videos. So, that includes both for the language model and for the diffusion based model. So, diffusion models, here you can see that in the separate clusters are basically used for the medical image synthesis, augmentation, and various kind of simulations. So, which are is increasingly used in training and research. So the key takeaway from this slide is that these paradigm are not competing technologies. So they are basically nested and overlapping layers of same AI ecosystem, and each are serving different purposes. So in healthcare, the real values comes from choosing the right paradigm for the right clinical problem. So whether that is a simple machine learning model for the risk prediction, or it can be a deep learning model for imaging, or large language model for clinical workflow support. So understanding these kind of distinction basically help us move beyond various buzzwords and towards a responsible and effective AI based deployment. I would want to tell you one more thing, like generative AI in medical image analysis. Generative AI plays a very important role, because particularly in India, because we are suffering from the data and all. So for creating appropriate models, we need a sufficient amount of data. So generative AI is very important for that. So ML algorithms in healthcare application fields. So this slide basically shows where the machine learning is actually being applied in healthcare today, not in theory, but in practice. So machine learning algorithms are increasingly embedded across the healthcare ecosystems, which supports both clinical decision making and various system level efficiency. So first of all, diagnosis and the disease identification. ML model can learn various kind of patterns from clinical data, laboratory values, imaging, and the patient history to assist in detecting diseases earlier and more consistently. And this is particularly useful for the screening purposes and early to identify the early warnings in systems. Second is the predictive medicine. So here the machine learning is used to anticipate future outcomes such as disease progression, complications, or risk of readmissions. So basically, this enables proactive care, which allows clinicians to intervene before a patient's conditions worsens. The third one is medical care personalization. So ML basically can helps uh, to identify particular treatment strategies based on the individual patient characteristics that combines like clinical previous clinical history, imaging, and sometimes combined with the genomics data. So this supports the shifts towards the precision and personalized medicines, specifically in the oncology and the chronic diseases. Sorry. Sorry. The fourth one is administrative workflow optimization. A significant amount of healthcare effort recently is spent on the non-clinical task, and ML can streamline scheduling, billing, resource allocations, and operational planning. That basically reduces the delays and the clinicians burnout. Fifth one is the medical image analysis. Just for the information, I work in the area of the medical image analysis only, and this is one of the most mature ML applications areas, because algorithm assist with the detection, segmentation, and the quantification in radiology and the pathology, which improves consistency and the accelerating workflows. The drug discovery, machine learning basically accelerate target identification, various molecule screening, and the trial optimization, which significantly reduce the time and cost in the drug development pipeline. The last one is the medical document flow, MLP, ML and recently NLP based methods basically helps automate clinical documentation, various kind of insight extractions from the unstructured notes, and reduces the documentation burden on the clinicians. So the key message of this slide is that machine learning is in healthcare is not confined to one domain. So it spans diagnosis, prediction, personalization, operations, and innovation. So that basically creates value across the entire healthcare life cycle. So the real challenge now is not whether ML works, but how responsibly and effectively it is integrated into the into the current clinical practice. So now let us briefly look at the core machine learning algorithm. I'm not going into the detail of it. So these are the foundation of the many healthcare AI-based systems. So at the center, I mean, this is machine learning. There are a couple of various machine learning algorithms like linear regression. It's one of the most simplest model. It is used to uh, this one. It is used to predict the continuous values such as disease progressions, rates, or length of the hospital stay. Despite its simplicity, it remains highly useful and interpretable. We can have the logistic regression. It is widely used for the binary classification task. In healthcare, it is often used to predict outcomes like disease presence or absence or risk categories, that makes it popular in the clinical risk models. We have support vector machines or SVMs, which are powerful classifiers that work well with the high dimensional data, and they are commonly used in the biomedical applications such as genomics, radiomics, and image-based classification tasks. We can have the k nearest neighbor, that is an instance-based methods. It makes prediction based on the similarity of a new patient to previously seen patients, so that is useful in case-based reasoning scenario. We can have the naive based classifier, that is a probabilistic based model, which is a little computationally efficient, and it is frequently used in text based applications such as clinical document classification and information extraction. We can have a random forest. It is basically an ensemble method that combines multiple weak learners in the form of decision trees, and it is basically robust to noise and widely used in healthcare because it provides good performance while offering some degrees of interpretability through various kind of a feature importance. And the last one is we can have the K-means, which is an unsupervised learning algorithm. It is used to group patients into clusters based on a particular type of similarity that is often applied in patient stratification and phenotype discovery. So we can choose any algorithm as per the requirement. The choice of the algorithm basically depends on the clinical problem, the types of the data that we are going to use, the need for the interpretability, and the deployment context. So in healthcare, simplicity, robustness, and the trust are often more important than algorithmic complexity. So now let us move one level deeper from classical machine learning to deep learning. So what you see on this slide, it is a simplified representation of the deep neural network, which is the backbone of most modern AI system in healthcare, specifically in imaging, signal, and the complex multimodal data. So on the left, we have the input layer in healthcare. These inputs could be any kind of data, for example, like pixel values from an MRI or CT scan, or it could be ECG or EEG signals, uh, any kind of laboratory values, clinical features, genomics information, proteomics based information. From the we can have those information from the patient records. So these inputs by themselves may not be very informative. So their real value basically emerges as they pass through the network. So okay, so in the middle, you can see that multiple hidden layers. So this is what makes the model basically deep. So based on these various kind of hidden layers, we can call it, we basically used to call it as a network. So each hidden layers basically learns a progressively more abstract representations. So each layer learns simple patterns. Intermediate layers learn more complex structures, and the deeper layers capture high level clinical features. So for example, in medical, if we talk about the medical imaging, so earlier, I mean, for the first layers detects ages or texture, middle layers basically detect anatomical structures, and the deeper layers basically it may recognize the pathological various kind of pathological patterns. So importantly, these features are not manually designed; they are basically automatically learned from the data, which is a major strength of the deep learning. So on the right, we have the output layer. This could represent diagnosis, a particular risk score, heterogeneity score, a probability of the disease, or a predicted clinical outcomes. So basically, deep learning transforms a raw medical data into clinically meaningful predictions through this layered learning process. From starting from the input layer, various kind of multiple hidden layers, and the output layers. Okay, so why is deep learning so powerful in healthcare? Because healthcare data, as I discussed earlier, that healthcare data is high dimensional, non-linear, multimodal, and often too complex for the rule-based system. So deep learning excels in exactly these conditions. So however, it is important to remember one thing: a limitation, like deep learning models are in general less interpretable, so which raises a concern around trust, transparency, and the clinical acceptance. But we can currently